So do you remember the story from last class? It cannot get rid of the radical sign until what? Do you remember the bodyguard story? Is our cube root alone on the left side? No. So step one is always to do what? The left side. Make sure that your radical term is alone. Always. Make sure the radical term is alone. So if you have anything next to the radical, either on the left side or right side, doesn't matter. If you have anything next to the radical, we want to get rid of that. So here we have 4 next to the radical. So either you can subtract 4 or you can add the radical term to both sides. So in my morning class, I added the radical term, but here let's subtract. So if you subtract 4 from both sides, we get negative cube root of x minus 8 equals negative 4. Is our radical term alone yet? No, because you have the negative sign in the front. So you divide or multiply, it doesn't matter, by a negative. So you get cube root of x minus 8 equals, what is negative 4 divided by negative 1? Positive 4. And now is our radical term alone on one side. So that means it becomes very weak. So we can apply its power on both sides. So which power is supposed to apply? 3, good job. Because we have cube root. Cube root needs cube power so that we can cancel them out. So we have only x minus 8. And what is 4 cube? 64, you remember that? Ooh. And now to get the epsilon, what is our next step? Add 8 to both sides of the equal sign. That gives us x equals 72. Since we are dealing with cube root, so technically you don't have to check the answer. For any type of odd root, answers, they don't need to be checked. But let me check anyway. We have 4 minus cube root of x minus 8. That has to be 0 when you substitute, the other one. When you substitute x with 72. So we have 4 minus cube root of 72 minus 8. We want the result to be 0. So we have to do the cube root first. What is 72 minus 8? 64. And what is cube root of 64? 4. What is 4 minus 4? 0. Do you have the same thing on both sides? Yep. So we accept our solution. This is the correct solution. Any question? I have to flip twice. So let me know when you're done with the left side. Come on, guys. How come you're so slow? Hmm? Great. Tell me what to do in the first round. Since our radical term is alone on one side of the equal sign, so we can go ahead and directly apply the square on both sides. Perfect. So this thing means we have x minus 3 times x minus 3. It's not x squared plus 9. It's x minus 3 times x minus 3. So get x squared minus 6x plus 9. So minus 2x plus minus 8x plus 12, and one side becomes 0. Mm-hmm. 6 times 2 is 12, 6 plus 2 is 8, and they have two negative sign. X minus 6, 0, x minus 2, 0. So x is 6, 2. Mm-hmm. Perfect. You're replacing x with 2 and x with 6. So 2 times 6. So square root of 9, I don't have space, sorry. 2 times 6 is 12. 12 minus 3 is 9. So your square root of 9, which is 3 on the left side. On the right side, we have 6 minus 3, which is 3. So left and right, they are same thing. So we accept x equals 6 as our solution. And how about the next one? 2 times 2 minus 3. So we have 4 minus 3, which is square root of 1. And this side gives us negative 1. Are the same? Mhm. But here it's square root of 1. Square root of any positive number always has to be positive. If you solve for x, then you don't know what is your number. Is it positive or negative? So you have two choices. But when you know your number, it's 1. Getting the square root of 1 has to be positive 1. So the only solution we have is 6. So in the multiple choice, if you see x equals 6 and x equals 2, and without checking, you said, oh, both of them are correct, you get 0. 100? Oh, down here, by the times here? Yeah. Square root of 9 equals 3. Oh. Oh, and here we have 6 minus 3 equals 3. So they both are same number. Robert. No, because square root of 1 is 1. But on the other side, you have 2 minus 3, which is negative 1. 1 and 1 is not negative 1. So we don't have the same number on both sides of the equal sign. Any other question on the first one? Who would like to try the next one? Okay, let's do it together. Tell me the first step. We have a bodyguard 4, so we need to subtract that. So 3x minus 8 equals x minus 4. We square both sides. So 3x minus 8 x minus 4, x minus 4, but when you multiply them, what do you have? X squared minus how many x's? Only 4? 8x. Because one 4 is here, another 4 is here. Or is it a minus for twice? Sorry, I didn't hear that. I would like to write the final result. Let me take more space. So it's always foiling. It's never distribution when you add or subtract. You must foil. Okay, then what do we do? Let me rewrite. We have 3x minus 8 equals x squared minus 8x plus 16. Minus 3x minus 3x plus 8. We want to have 0, so everything cancels out on the left. And what do you have on the right? X squared minus 11x plus how many? 24. Is it factorable? Negative what? Negative 8, negative 3. Perfect. You guys are doing great. So x minus 8, 0, x minus 3, 0. That gives us what is our x? And are we done? No, you must check both of them. And when you check, you have to use the equation with the radical. So 3x minus 8 plus 4 equals 6. X. 3x minus 8 plus 4 equals 6. We have to check it twice for two solutions, for two numbers. Here our x is 8, so every x you see, there will be 8. Here our x is 3, so every x you see, they become 8. So 3 times 8 minus 8 under the radical. Outside it's 4. We want the answer to be 8. 3 times 3 minus 8 inside the radical. Outside 4, and we want the results to be 3. So inside the radical, what do we have? 24 minus 8, and that is how much? And what is square root of 16? Plus 4. Do we have the same thing? So we accept x equals 8 as our solution. How about the next one? 9 minus 8 plus 4, which is 1. And what is square root of 1? And what is 1 plus 4? 5. Do we have the same thing? No. So can we accept x equals 3? The only solution we have is 8. Sometimes both of them work. Sometimes only one work. Sometimes none of them work. Okay. When none of them work, we call them no. We say no solution. Those are bad equations. And we have one solution here. And sometimes you will see both of them work. So either it may have one solution, zero solution, one solution, two solution, or no solution. Now the last one. Who would like to try the last one? Linda, you already tried. Let me see if anyone else want to try it. You also tried once. Anyone else? Okay, Stephen. Both radicals. So as long as one of the radical is alone on one side, you're allowed to apply the power. Fortunately, both are alone. So yep, we can go ahead and apply our power on both sides. Since we are dealing with square root, so I need to apply square power. Leandra, knock on. So in both cases, the radical and the exponent cancel out. We have the inside 8x minus 3 equals 3 minus 8x. Now it's a simple algebraic equation without any radical. So what's next? Leandra. Add 8x and subtract 3. So 0 equals minus 6. You don't have to actually do that. If you want, you can only bring the x together, number together on the other side. You get the same result. Okay, so we have everything on one side. What's next? How? What's the relationship between 16 and x? What symbol you see between them? Nothing, right? So how they are connected? The multiplication. So you cannot subtract, you can do it to do division. But you cannot divide first. There is a problem with this. Next to 16x. You must get rid of the 6 first. So add 6 to both sides. You get 16x equals 6. And now to get the x alone, we can divide. Now 6 and 16, are they divisible by anything, any number? By 2. So it divides both of them by 2, and we get 3/8. Are we done? No, we are dealing with even root, square root. So we should check. Square root of 8x minus 3 should be same as 3 minus 8x under the square root. Just because you see a fraction, don't get scared. Every x you see is 3/8. So it's 8 times 3/8 inside the radical on the left side. And it's 3 minus 8 times 3/8 inside the radical on the right side. You're in the wrong class. Now, to make our life easier, what do you think we should do? Cancel. Good job. See, 8 on the numerator, 8 on the denominator. As long as one on the numerator, one on the denominator, we can always cancel them. 8 cancel with 8. This 8 also cancel with this 8. So what do we have? 3 minus 3. And on the right side? 3 minus 3. We don't have to go any further if you see the exact same things. Do you have the exact same things on both sides? Yeah. That's any question? Was any step unclear, confusing? With this, we are done with solving radical equation. Definitely one of them will be in the final. Definitely. So make sure you check your solution because final exam, most likely it will be in the multiple choice part. So you'll see all types of choices. Next comes complex numbers. Complex numbers means imaginary numbers. Where do we get them? We get them from where is something you cannot get in real life. For example, if you're trying to solve x squared plus 1, you end up getting x squared equals -1, so x equals square root of -1. And you already know, right? So somehow mathematician found out that the square root of -1 is I, which is the imaginary number. Now, anytime you have square root of -1, it turns into I. And if you multiply two i's, I times I, it means you have square root of -1 times square root of -1. So you end up getting square root of -1 square. So you get -1. I'm doing something wrong here. I shouldn't do that. Just remember square root of -1, sorry. Anytime you have I times I square, it turns into the real number negative. Okay? So square root of -1 is I, but I square, if you have two imaginary numbers, they're multiplying, they turn into real number, -1, not positive. So remember this. Not any other number. I square is -1. Now, based on that, we add them, subtract them, multiply them, try to divide them, simplify them, or we do all this. So let's start with a simple thing. If you're square root of -a, it could be any number. In order to get the I out, first we split them into two pieces. One is square root of -1, and then one is the real number without negative sign. Now, this thing is unreal, so it becomes I. And based on A, if it's perfect square number, we get a whole number back. If it's not a perfect square number, we get the same thing back. For example, square root of -16. -16 is not real under the square root. So we break it into, but before that, we do know that -16 is -1 times +16. That's why we can split them into two pieces. One is square root of -1 and one is square root of 16. The -1 is unreal. It turns into I. But what is square root of 16? Is it real? It's 4, right? So we get something real. So something is unreal, something is real. We put them I. So you write the real number first and then I. If your number is a whole number or decimal number, you write the number first and then I. But if you have a radical, We write the radical later and I first. I mean, we can write either way, but my method wants you to write radical later and I first. How about the next one? What do you think about the next one? We have double negative. What's the role of the first negative? First negative is what? Bring it down because it's a multiplication. Anytime you start with a negative, it means it's a multiplication. So for every multiplication, you bring it down. And then you see the negative 9 is negative 1 times the positive 9. So it becomes negative 1 under the square root and positive 9 under the square root. Negative 1 under the square root turns into I. And do you know what is square root of 9? Today. So what is our final answer? Negative 3I. That's how we simplify them. 7 and 18, are they proper square numbers? No. So we're not going to get the results like the left page. How do you split the negative 7? Square root of negative 1 and 7. What do you get from here? And from here? Same thing, because we don't know what is square root of 7. Square root of 7. If you cannot simplify, leave it alone. We can simplify. Keep simplifying until we cannot simplify. This is what my method wants. But in real life, if you write negative 7 and then I, it's also fine. Real life. I mean, I shouldn't say real life, my bad. I should say on paper. For real number, the number comes first. I know that's not variable, sorry. I. But for ridicule, it's kind of complicated. Like if you try to put this on my method, you write negative 7, and then you may forget to go outside of the ridicule and you write I. So if you do that, my method cannot recognize what is this. And same thing in real life, it's hard to recognize, but we consider that, well, we give them the benefit of the doubt. Like we think you're doing the right thing, but this is actually the best. Keep the eye, to avoid the confusion. Okay, great. The next one. Negative comes down because it's extra, and negative 1 and 18. But can you split 18 more? What two numbers makes 18? 9 and 2. So we can actually split here, square root of 9 and square root of 2. If you can split a number more and get a perfect square number, go ahead, do it. You cannot, like 7. Nine times 2 gives us 18. So we have negative from here. The negative 1 under the square root gives us I. Square root of 9 gives us 3. And square root of 2 gives us same thing. Square root of 2. So when you combine all of them, what do you have? I square root of 2. This is for my method. But on paper, if you want, you can write -3 square root of 2 and then leave some space so that you can understand your I is not inside the radical. On paper, if you can see like it's not inside, it's correct. My method, like if you put it here, you may get into trouble. Like if it cannot recognize it's outside, it will give you 0. Either answer is correct, but if you put it right here, see on the paper, I can see in your space. On my method, it doesn't recognize it because of the errors we make. But either way, like either method is fine, okay? Either format, not method, sorry. So we have enough knowledge to go and multiply the imaginary numbers. When you multiply the imaginary numbers, it's same as you're multiplying normal variable. Like this is same as -3x times -9x. Same thing, okay? But there is one difference. If you multiply -3x times -9x, what do you get? You're multiplying -3 times -3x minus -9x. So what do you get? Not 12, right? 27. So -3 times -9 gives you 27. And then x squared. So for x, we get 27x squared. We get the same thing for I. It's -3 times -9, I times I. That gives us 27I squared. Now, when you x squared, we stop or like was done. But for I squared, it cannot stop because I squared is a real number. What is I squared? -1. So you must convert the imaginary number into real number. So it's 27 times -1. So the answer is -27. So this is the difference between other variables versus I. When you have I squared, you must convert this into -1. But when you have x squared, y squared, z squared, a squared, b squared, c squared, you just leave them alone. But I squared cannot leave them alone. Clear? Question? Okay. But not always you're going to see the I. Sometimes they will not give you I, but they'll give you imaginary numbers. If you don't see I, but you know you're working with imaginary numbers, you always have to bring the I first from the imaginary number and then multiply. If you try to multiply without bringing the I out first, you're wrong. What do you mean? It's the I squared. I times I is I squared, and I squared is. No, I is square root of -1. So when you have I times I, it turns into the real number -1 without the square root. Okay, so here you must pull out I first to multiply. Anytime you're trying to multiply imaginary numbers, always pull out the I, always. So what do we have here? -1 and 2. -1 and 14. So this gives us I square root of 2, I square root of 14. So now we see we have I times I, and we have square root of 2 times square root of 14. Can we multiply the inside? What's the condition to multiply radicals? They have to have the same radical sign. And we do have the same radical sign, square root, square root. As long as you have the same radical, it keep the radical and you multiply the inside. 2 times 14, that gives us 28. And what is I times I? I square. And what is I square? -1. So in other words, we have negative square root of 28. See, we multiplied the imaginary numbers, but we ended up getting a real number. But do we stop here? Remember, anytime you can break your number, you always have to break it down to simplify. Can you divide 28 by any perfect square number? Like by 4 or 3 square is 9, 16, 25. Can you divide your 28 by any one of these? 4. So you have to split it. 4 and what? 7. What is square root of 4? So -2 square root of 7. And now you stop because you cannot simplify square root of 7 anymore. On the first step, let's see why not. Let's say you decided, well, I don't want to waste my time doing all these things. Let me just simply multiply the inside. So square root of -2 times square root of -14. You decided to multiply -2 times -14. That will give us, what is -2 times -14? Positive 28. And you already know positive 28 is square root of 4 and square root of 7, right? And square root of 4 is 2, square root of 7 is square root of 7. Do you have the same answer? See? That's why. Because you are not starting with something real. If it's not real, you cannot multiply. In order to multiply the inside, you have to be real number, positive number. That's why you always pull out the immediate part from your complex number, and then you multiply the real numbers. Exactly. So you got a 2 squares is 2. It becomes really much easier. Yvette.
No, I'm like when just break down what the 7
7 and 2. Yes, you can do that.
Yeah, that's what we did for the 18, so I was saying.
Okay, let me do it then, no problem. So -2, second method, okay? Second, blah, 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 times -14. So negative, side the radical, oh, very minus. We have -1, 2, -1, and 14 is 2 times 7. So we can do 2 and 7. We get I square root of 2, I square root of 2, 7. We can combine these two, we get I squared. We can combine these 2, we get square root of 2 square. That means the single thing is square root of 7. I square gives us -1. Radical and square cancel out. We get 2. And this becomes square root of 7. So then the answer is -2 square root of 7. Like if you don't want to simplify 28, you can simplify the 14. Any other question? Now in division. Well, you can do the same thing. First, pull out your I and then work with the real numbers. So I square root of 90, I square root of 2. We have the exact same thing, they cancel out. And we can have a big 90 over 2 because they're real number, we can combine them. Can you divide 90 by 2? How much is 90 by 2? 45. Can you simplify 45? 9 and 5. So square root of 9 and square root of 5. So what's the final answer? 3 square root of 5. So see, when you divide two imaginary numbers, you get a real number. When you multiply two imaginary numbers, you get a real number. So it's like negative. If you have negative and negative, they turn into positive. Like imaginary turn into reality. Okay, so we have enough information how to simplify imaginary number, how to convert negative sign under the radical to I. And now we are going to do addition, subtraction, and more multiplication and division. So imaginary number, we call them the group. In the group where the imaginary number belongs, we call them complex numbers. So complex number, they have a format, the real number first, and then the imaginary numbers. So it's a plus bi, a and b, it could be any number. Could be whole number, fraction, decimal, anything. We can write a real number as a complex number by adding 0i. Or we can write a complex number with a real portion by adding a 0. In other words, we can write anything as a complex number with a complex format. Why do we care? We care because when you add and subtract, we add and subtract the real portion with real portion and the imaginary portion with imaginary portion. Flip, 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 I have to flip twice. I had this big chart, I still copied the chart this time. So ignore this chart. Okay, so when you add or subtract, add the real with the real, imaginary with the imaginary, and then at the end, write them as real first and then the I part. For example, this one. We are subtracting 6 minus 5i from 8 minus 9i. So just like normal XYZ variable, it is the exact same thing. You can treat the I as X. And when you bump into X squared, it just becomes -1. So we have 8 minus 9i is subtracting 6 and plus. Anytime you subtract, the sign inside whatever you're subtracting will change. So instead of minus 5i, it will turn into plus 5i. And then you combine like terms. What like terms you see here? What are the like terms? 8 and 6. So what is 8 minus 6? 2. Anything else? Negative 9i and positive 5i. Negative 4i. And that's it. That's all we have to do. Combine like terms and put them together. Any question? Try the next one. For each one, nothing changes, no sign. But anything you subtract, you always.
Well, that's all.
What do you mean? When you subtract, you don't multiply. We only distribute in multiplication. So try the next one. You already see the I, but there is one more point you don't see the I. So let me know if you're done with the left page. Is anybody still doing the left page? No? Okay. Then you have 2 examples. And in the exam, I'll give you something like this. I already posted the review sheet for our next exam on Brightspace. So take a look at that. Our next exam will be based on entirely chapter 10 and 11. So it will be a big exam, around 16 to 20 questions. And so in class exam, we have 1 hour, 15 minutes. In the final exam, we have 2 hours straight, bless you, and 30 questions. So I noticed that I actually don't give you only 1 hour, 15 minutes. I give you more than 1 hour, 15 minutes in class, right? So I give you around 1 hour, 30 minutes. So in 1 hour, 30 minutes, it's supposed to do at least 20 questions. So if I take the scenario from the final exam, then giving you 20 questions for 1 hour, 30 minutes makes sense. You have to do them in the next exam, not fifth exam, but the final exam. You're going to do 30 questions in 2 hours. So fifth exam would be a good practice for the final exam. You'll know how to maintain your time. Okay, so be ready. It will be 5/9, May 9th, and I already posted the review sheet for chapter 10 and 11. And your final exam will be 1 week after our 1 week and then 2 days. So within 10 days. I forgot the date, 20 or something. Yeah, 20. So our exam is on the 9th. Then we have this week, is April? No, this is May. So our exam will be on 9th. Then we have 2 class, I think, or 3 class, I don't know. So I'm going to go over all the materials again for a review. And your exam is 8 a.m. in the morning. And if I cannot finish everything from chapter 10, chapter 11 before 6 or by 6, then I'm going to skip that for that exam and then go over that after the exam. So until 6, whatever we can cover, our exam will be based on that. Catherine?
Do you know where Congress is located?
No, not yet. But it will be in a big lecture hall because I have 2 sections. For 2 sections, is always lecture hall. Okay, are you guys done? Robert, question? If you add, it's I. But if you multiply, it's I square. So I treat them as X. If I is X, what is X plus X? Really? And what is X times X then? X plus X is 2X, right? X times X, you multiply the base, so you add the powers, so it's X squared. Same thing I plus I is I, but I times I is I squared. If, okay, ready? Who would like to try the first one on the left page? No volunteer? Go ahead, Robert. Negative turn into positive 6. Minus 3. Minus 7i. 3 minus 7i. See how easy it was? It may look tough, but actually it's kind inside. Yvette.
Complex numbers, because I got it wrong, but just because for the -7i, I did the negative, I did square root -1. You know,
No, you don't have any square root given to you. When the square is given, you pull out the I. But here they already gave you the I. So there is no more extra square root. Unlike this one. On the right one, they did not give you the I. So you have to pull out the I first. So who would like to try the next one? Little bit challenging one. Any volunteer? Let me tell her you already did one. Go ahead, Leandra.
I pulled out.
Mm-hmm. Mm-hmm.
Where
Mm-hmm. This is real, so you don't have to split it. It's simply the real number 10. Perfect.
yeah, that's I, and then the second was
What happened to the square root of 50? Mm-hmm. 25 and 2. Perfect.
but it's 5.
Let's keep going on. Mm-hmm. I. Square root of 9 and square root of 2. Minus 10. Only 5. How, how do you combine addition or multiplication? It's 6i square root of 2. And the first one becomes 5i square root of 2. Do we stop here?
You can come back I.
We have the same radical, also same I. If you have the same other portion, you can combine their coefficients. So what do you have? 11I minus 10. Now can you stop?
No.
We cannot. 11I root 2 is fine, no problem. You can write 11 root 2I, no problem. But what's wrong with this format? Is this the format of the complex number? Complex number says you have to have your real number first. So which portion is real? This portion or this portion? Negative 10. So you must write negative 10 first and then the imaginary portion. So what sign the imaginary portion has? Positive. So plus 11, let me write square root first, it looks weird. Square root and then I. Imaginary numbers or complex numbers. Now, that's how we simplify. We add them, subtract them, simplify them. The end result, we want the real number without the I. And then the second term can have the I. I can be with 11 or I can be after the root 2. We have 2, I, 3. There is no visible symbol between them. When you don't have any visible symbol, it's always multiplication. So it's 2 times I times 3 times square root of 2. 2 and 3 gives us 6. I is I, square root of 2 is square root of 2. 7 has I, 3 doesn't. I is just like X. If you don't have your X, you cannot add or subtract 2X's. Now, how do you multiply? Well, we already know how to multiply them. So it's not anything new. Let's do a multiplication. We have a monomial times a binomial. Distribute. Just like normal variable. What do you get from the first distribution? 12I. 2 times 8. 16. And I times I square. What is I square? Anytime you see I squared, you cannot leave it alone. So this turns into negative 1. So we get 12I minus 16 times negative 1. So 12I plus 16. We cannot stop because this is not the correct format. It's like wearing your clothes. You have to wear the top on the top, pants on the bottom. You cannot put pants on the top and then shorts on the bottom, right? So you have to have your correct format. Otherwise, it's bad. It's weird. Now something comes that will be in the final. So this is a question you'll want in the final. Multiply binomial by binomial. But you already know how to do that because we did so many examples with binomials, right? So let's go ahead. What do you have? 54. And the next one? Negative 63I. And then the other way around? Plus 12I. And lastly, negative 14 I square. This I square is negative 1. That means the negative 14 turns into positive 14. And do you see any like terms? What are they? 63I with the negative sign and 12I in the positive. We are going to bring down 54 right now and then combine with that later. So in the middle term, what do you have? Negative 63I plus 12I. Minus how much? How much? Say it louder, I can't hear you because of the people outside. 51. So negative 51I. Do you have more times to combine? 54 and 14. So what do you have? 68 minus 51. And now you're finding. It's simple, not bad. Just like the variable ID. Before you go, one more example. Never mind. You can try one and then in our next class, when you come back tomorrow, we are going to try all of these, okay? So if you want, you can write them down, try at home. And then tomorrow when you come, you don't have to do anything. Or you can do them at home and then do them again tomorrow. That's your practice. So goodbye, everyone. See you again tomorrow. If you have any question, please talk to me.